Okay, let's take a look at a couple more examples to highlight how relative difference helps us think about the change in context. So let's say your instructor tells you you're going to get an additional 2 points on a recent test or quiz. So let's pretend that we're working on a quiz that has a total of 10 points, right? And let's pretend you got a 6 out of 10, which is a 60%. So when you're given the extra 2 points, it now becomes an 8 out of a 10, which is a 0.8. So we go from a 60% to an 80%. That's going from not passing, like a 1.0, to a 3.0. So that jumps 2 letter grades. Awesome. That's amazing. Let's say that we had a test. They're often out, let's say, out of 100 points. And we'll keep the same percentages. You got a 60 out of 100, so a 60%. Given those 2 points on the test, you'd now get a 62 out of 100, or a 0.62. Not really affecting your grade at all. This is still a 1.0 in both cases. Using the concept of relative change, we can note that the change is 2 points. So for the quiz, we would have a 2 out of 10. This is the old value. And that means you're being given 20% of the points as, say, extra credit. Whereas with the test, when we do 2 out of 100, the amount of change is only 2%. So that's a 2% change in your grade. Not super helpful, not much to get excited about. And you watch, I'm guilty of this as well. Professors will toss out points like this for students, knowing that it really has no effect on your grade, but often students get real excited about doing that extra credit. There's something about the psychology of it. Okay, so then we get to this idea of the federal deficit. The author says back in 2011, the government spent $1.298 trillion. That means they spent more money than what was brought in. And he's like, hey, let's just round this up to $1.3 trillion. And then let's calculate that relative difference. And then he notes, hey, if you're clever about this, you won't have to work with really large numbers. Well, note that 1 trillion in let's call this standard notation. Let's see, 100,000, 100 million billion looks like this. So 1.3 trillion would look like this. Well, if I wanted to not use all those extra zeros and use, say, in billions, because this is the amount of change we had, 2 billion, I could say, well, this is the billions section. So this is $1,298 billion. Likewise, this $1,300 billion would be $1,300 billion as well. So using our new minus old formula, we can calculate that relative change. Now the question is, what do we want to use as what? Do we want to state the rounded up value is the new value and the original value to this? And let's do that. So we would do 1,300 minus 1,298, noting these are all in billions. Since they're all in the same scale, the billions would all cancel out, the dollars would all cancel out, and we'll be left with exactly just a unitless percentage that we would then have to interpret in context. So in other words, 2 billion divided by 1,298, let's check what that turns out to be as a percentage. And I'm getting 0.0015 if we round to 4 decimals. Seems like a reasonable rounding. 0.0015. So in terms of a percentage, notice this is approximately 0.15%. Doesn't that blow your minds? $2 billion, a number that is hard for me to fathom in terms of having that in my bank account, is only 0.15% of the extra money we spent over our budgeted amount of money back in 2011. This is why thinking about $2 billion relative to the overspending, that's like nothing, right? It's a minuscule amount. It's like you and I dropping pennies on the street and saying, forget it, I don't want to bend down and pick that up. All right, let's look at one more. So here we got a college football team won 5 games and lost 7 in 2014. And then the next year, they won 7 and lost 5. Well, a basketball team, which, as you may know, basketball teams play more games than football teams in general. They won 10 of 34 games in 2014, and then 15 of 34 games the next year. So, which team had the most significant improvement? Well, there's lots of ways we could look at this. If we use the relative change formula, we can note that, well, let's see. For the football team, in the first year, they played 12 total games, and they won 5 and lost 7. And then the next year, they changed that, and they won 7 and they lost 5. So we could do percent winning. So we could do 5 over 12 equals something versus 7 over 12. Let's get those numbers real quick. 12 and 7 divided by 12. So 0.417 versus 0.583. Okay, so definitely an improvement, of course, in the percent won. That's what these percentages represent. Let's do that same analogy for our basketball team. So noting here, they've got 10 out of 34, so they have 34 total games, and they won 10, which means they lost 24 games. And then the next year, they won 15, and they would have lost 19. So using our same percentages, we could say first year they had 10 out of 34 as the percent won, and then 15 out of 34 as the percent won. Note, we're doing the percent, the games won to the total. That's the percent we're calculating here for each. So their first season, they were a 29% winning, and their second season, they are a 44.1% winning. So which one, our question here is which had the most significant improvement? I don't know that this is the best way to look at it. If we look at their starting places in terms of percent won, the football team was ahead, and so they didn't increase as much between the two, although they still have a better record. So let's do the change in wins, okay? So in this manner, we're going to do what is this change relative to the previous year? So we're going to do 7 wins minus 5 wins divided by 5 wins. That's going to be the relative change of winning games. Down here, we're going to do the new year is 15 wins minus 10 wins divided by 10 wins. Here we're applying the relative change formula to hopefully get us a better picture of what's going on. Now notice how I type this in Desmos. 7 minus 5 parentheses divided by 5. You got to make sure that becomes a fraction. So that in the numerator, notice if I don't do that, in the second one, I get 15 minus 10 over 10. That's not what I wanted. I wanted 15 minus 10 to happen first, so I did parentheses, then divided by 10, 0.5. Notice, and looking at it this way, the football team had a 40% improvement in terms of the number of wins, and the basketball team had a 50% improvement in terms of the number of wins relative to the previous year. So the basketball team had a more significant change, although they still have a worse of a winning season, right? So the football team has a better record and relative record.